Hello students, a very warm welcome to JEE English by Unacademy, India's leading and largest JEE test preparation platform, and we are on to a very interesting lecture on electrostatics. Today we are going to get started with the electrostatic potential energy, how to work around, like first of all let's start by understanding. Hello students, a very warm welcome to JEE English by Unacademy, India's leading and largest JEE test preparation platform, and that being said, today we'll get started by understanding what is electrostatic potential energy and how do we work around different kind of problems. Typically, the kind of problems that you deal in your you will deal in your JEE Mains and JEE Advanced. And that being said, students, I'm Murlidharan Gopalakrishnan. I completed my MS in Electrical Engineering from CU Boulder, and I'm also an IITian who completed BTech from IIT Guwahati. I have 4+ years of experience preparing students for IIT JEE and other competitive exams. And I filed 25 patent applications in India and abroad. And guys, the most competitive gamified IIT JEE battle ever is going to be live again. I mean, like, you can compete live and win lots of rewards and prizes online, that too from your home. So all you need to do is just enroll to this Unacademy Combat, and also apply Murli live code. So don't forget to enroll to this Unacademy Combat, guys, because this is going to be the most competitive IIT JEE battle ever. And not only that, it's going to be an awesome kind of training for your JEE Mains and JEE Advanced preparation. And the prices were range from Apple laptops to Amazon vouchers. So think about it. So if you're the first, if you're winning the first prize, you're probably going to get an Apple laptop, MacBook Air, and there are many Apple products as well in the price list, and lots of Amazon vouchers. And guys, yes. That too in a very gamified and interesting manner. So compete and do not miss it out. The next event is going to happen on 22nd of November. So don't miss it out, guys. And that being said, UCL is also back. UCL Mathematics is going to happen on November 18th. And try to attempt it live and win lots of prizes and scholarships. And of course, first 10 ranks are going to get prizes worth 10,000 rupees. And 11 to 30 are going to get anywhere prizes worth 5,000, and 31 to 50 anywhere around 3,000. So it's worth your time, guys. So try out this UCL Mathematics Unacademy Champions League is also back. So make sure you're attempting this live exam and winning some prizes and scholarships, and that too at 6 p.m. on 18th of November. So yes, guys, and that being said, students, if you're not yet on Telegram channel, do kindly get onto our Telegram channel so that you can get timely updates on every such class that we conduct on YouTube, or any class that we conduct on Unacademy Learning. All you need to do is type in Unacademy on your Google Play, Telegram, and download it from the Google Play Store and App Store. And just click on to this link. This link is available in the description box below, guys. So yes, first of all, download the Telegram app from your Google Play Store and App Store, and then click on to this link. This link is available in the description box below. You can click on to that little extension bar and find this link. You can also type in JEE_English, and what do you get? You get live timely updates on every class that is being conducted by our JEE English team. And that being said, students, if you have not yet covered units, dimensions, and measurement yet, and if you're a 2021 or a 2022, especially 2021 aspirants, in class 12 and droppers, guys, this is the ideal time to do it, because first of all, this is going to be a less time consuming topic. And not only that, typically you get one question or two questions every year in your JEE Mains, and combined with your JEE Advanced, anyway, you can expect 3 questions. So yes, and this could be the easiest topic. All you need to do is attend 4 back-to-back session along with a 5th model problem session. So these 4 back-to-back sessions were conducted by me from 19th September to 22nd September. And guys, why this is the best thing for your JEE preparation at the moment? Because it's less time consuming, which is very important for 2021 aspirants especially. And 2021 aspirants, this is something that you want to cover, and you get a complete kind of understanding of units, dimensions, and measurements. This includes error analysis, dimensional analysis, different measuring instruments, least count analysis, and yes, of course, dimension units based problems as well. Everything has been covered, including in a fifth model problem session, which you want to attend as well. Along with this, there is attached another model problem session. So try to attend and cover all this five sessions. This is going to be the easiest one for your JEE preparation, and of course the less time consuming one and the definite weightage one. And that being said, students, if you have not yet downloaded Unacademy learning app from your Google Play Store and App Store, do download Unacademy learning app by just typing in Unacademy. And guys, once you type in Unacademy, the first search result is going to be Unacademy learning app. Just click onto this and click on this install button, the most downloaded learning app, guys. And not only that, you will get access to free of cost special classes like what you have seen before. And not only that, you can also attend quizzes, guys, live quizzes, live national level quizzes. Every week it is happening. Even tomorrow it is going to happen, so do not miss it out. It's going to be very interesting, so make sure you're attending these quizzes, and you are also attending the special classes as well. And yes, that being said, if you're looking for a champions tool for your JEE preparation, for your JEE Mains and JEE Advanced preparation, it's going to be Unacademy subscription. Why? We have the best educators across the nation on one platform, and you will undergo an extensive and an intensive structured program where you will get to learn from the best educators in a systematic manner. What do I mean by systematic manner and structured program? Guys, you get to get your doubts also clear from your best educators across the nation. Every fourth session is going to be a doubt clearing session, and guys, there are going to be mega quizzes and more in this like Unacademy subscription. And yes, of course, the most important thing would be also your test series. And dedicated quizzes and dedicated doubt clearing session is one which makes your concepts really perfect in that topic. And yes, guys, everything at actually it comes at an affordable price. And how do you get to this? How do you avail the subscription? All you need to do is click on the left hand top corner extension bar, choose plus, choose IIT JEE as your goal, and click on get subscription button. And guys, yes, not only that, it comes with a very interactive platform where you get access to leaderboards and dashboards. And yes, it's one subscription, and you can access as many programs as possible, all at a price of less than 70 rupees a day, 2,100 per month. Less than 70 rupees a day is what you have to pay for this amazing Unacademy subscription. And how do you get to this price point? You will apply Murlidharan coupon and get to this price point and avail a best discount on your any of your subscription purchase. And guys, that being said, this 24-month program is typically meant for 11th class students, 9th class students, and 8th class students. So yes, typically these kind of students may from 8 to 11, this is the ideal program for you, since it's going to be a 2-year long journey. And that being said, we also have convenient payment options for you, where you can split your payments into multiple parts using our pay in parts options, and you don't have to go through the burden of paying all the fee at once. And guys, we also have access to no cost EMI, again an interesting payment option where you don't have to bear any interest on your EMIs. You of course have to bear EMIs, but any interest on your EMI. So it's kind of you're splitting your payments into multiple parts, and you don't have to pay the interest on those subscription purchases, and you don't have to go through the hassle of paying all the fee at once. We also have other interesting payment options like debit card, credit card, and UPI. And guys, if you are a dropper, or if you're in 12th class, a 12-month program might be ideal for you. Why? We have dedicated droppers batch and 1-year program running for you. And not only that, by that time you typically know which are the topics that you're not perfect in, or that you haven't understood well. And we have programs, dedicated programs on optics, electromagnetics, many other things also being conducted by our JEE English team and by many other lecturers and educators on Unacademy subscription platform. So this way you can get to maintain the completeness, and 6,000 to 7,000 plus materials for your JEE preparation. And guys, not only that, you know what, 1,000+ live programs going on right now, and this all comes at a price of only less than 2,900, at a price of 2,888. Guys, don't forget to apply Murli Live coupon to get the best discount and to get to this price point. So yes, and that being said, you know what, if you're looking for a comprehensive, a complete course on optics from basics to advanced, guys, like my course is live on Unacademy subscription platform. You can enroll right now and get started with some of the concepts, and some of the concepts you will have to attend recorded classes. So start attending the recorded classes. If you're already on an Unacademy subscription, all you need to do is just enroll to this program and start attending this optics basics to advanced classes. And that being said, guys, yeah, Neha, yeah, Neha, ma'am, Army, yeah, of course, we'll start one shot as well, okay? We'll start one shot as well, we'll start some PYQ series. So, yeah, you can stay tuned. I'm sorry, guys, I'm not able to see your chat on time for some reason. And anyway, so yes, guys, so it's a complete coursework on optics from basics until advanced. Everything is going to happen, you know, on an Academy subscription. This includes, you know, all the topics of ray optics and as well as wave optics, everything in one course, 60+ sessions and 100+ concepts, 300+ model problems is what you can expect on this course that has just been launched, guys. So yes, if you even do not have any understanding of optics, you can get started, because everything will go from basics and it will move until advanced. So be sure to attend every class, because that's the way to move from basics to advanced. And guys, not only that, you know what, this course, in this course we'll be discussing so many model problems that ensures that you have your completeness in your optics. And that being said, guys, practice, and practice only makes human perfect. And today we are going to get started with a very easy topic of this electrostatics. Neha, sure, we'll plan for it. We'll soon get started with one shot series lectures as well. So okay, we'll do that. I don't think one shot is always a possible option for some of the topics. Some topics will require at least 3 to 4 lectures, etc. We can do that, of course, not a big deal. We will soon get started with that. And we'll do something around one shot or PYQ, something like the revision lectures for your understanding. Alright, guys, so let's get started on this, and do not forget to like this video, do not forget to share this video, do not forget to click on that bell button and that subscription button to get timely notifications. So that being said, let's first of all get started with understanding electrostatic potential energy. So what is it? Prox date. So what is the topic, Neha, that you want one shot lecture on? Is it on everything, or is it on few selective topics? So what is the thing that you didn't exactly get one shot lecture on? Which topic? Any specific topic as such? So yes, guys, so the thing is, so before we get started with electrostatic potential energy, we understand, you know, like the general form of, you know, basically 12th class topics. Okay, we'll do something like revision lectures, probably like, you know, A to Z lectures as well. But short lectures, yeah, we'll do that. Yeah, we'll soon get started with that. Okay, all right. So that being said, yeah, and that around 12th class topics. Of course. Electrostatics, guys, it's about practice. I think still it can be done. We'll see how do we do that. Of course, we'll do it. So yes, before we okay, let's now dive into the topic. Amazing, thanks for your input, Neha. We'll get into that and we'll get started with one shot lectures as well. And guys, let's get started with the electrostatic potential energy concept. So how does it all work? So the best analogy whenever we are talking about electrostatics is going to be like, you know, the mechanics part of it. And here, let's say we have a ball, you know, of you know, like mass m, and we lift it to certain height h, and we say that, you know, this ball has a potential energy now, and this potential energy is going to be mgh. Okay, and of course there is going to be a gravitational pull g by the earth. So this is a typical scenario where we are talking about, you know, lifting a ball and thus attaining Prox date, Neha, I'm not sure when would we get started. Potentially after electrostatics, we'll get started with one-shot lectures. Anyway, your one-shot lectures are, Neha, going on Unacademy Learning app, like A to Z series. We already did one for current and electricity. We did one for project time motion. We did one for we are currently on to capacitors. You can check out Unacademy Learning app. But I believe we will get started. Actually, the next goal was to complete something like nuclear, because it has a good amount of weightage for your JEE Mains preparation. So that was the reason, we haven't started with one-shot lectures, because there are a few important topics that need to be covered before, even we get into one shot. Because some topics can get you the score that you want very quickly, so we'll do it after nuclear. Okay, I think nuclear, post-nuclear, is there something magnetism has already been covered on JEE English, so we'll get started with one-shot lectures. Okay, all right, guys. So yes, let's say a ball has been lifted by a height h and it has a mass m. Then we say that this ball has now a potential energy of mgh. So in the same way, let's say there is a negative charge, something like capital minus q or something, and now you have lifted a positive charge from from near about that surface to certain height. Okay, to certain height or to certain distance. Then this ball over here, this charged positive ball, has also attained some potential. It's just an analogy. We'll understand the perfect definition of it. Yeah, sure. Absolutely. No worries. You're welcome, Neha. Okay. So this is the way we typically try to interpret things. So we say that this ball has now been lifted and this ball has gained some potential energy. And this is how we, even in case of electrostatics, we say that there is a charged ball with charge plus Q, and we say that this charged ball has now attained some electrical potential energy. Talking about electrical potential energy, generally denoted not with PE is something that we are used to, but I'm going to say as this guy's moved a distance d, this charge, let's call this charge to be plus q, and we said this was to be minus q, has attained some potential energy. Okay, that's going to be like some u12. Okay, you understand what is this u, etc. Alright, but if you remember, once you are moving this ball away from here, due to this ball, the ball also exerts some force on the earth, and there would be a potential energy of the system as well. This is the potential energy of the system that we are calculating. Right? So this is a similar thing, because we generally tend to ignore, ignore the fact that Earth is so large and we don't count the force of ball on the Earth. But this is the potential energy of the ball, not gained alone as a single particle, but as a system as a whole. All right, and similarly, even in this case, this whole system, this negative and the positive charge, has gained some potential energy. If this is just an analogy, we'll understand what does it exactly mean. Okay, what does it exactly mean? All right, so let's get into this point. So let's say you have two charges, q dash and q, and they are kept at infinite distance. Think about it now. Let's say they are kept at infinite distance. What is the force on them? The force on them would be 0. Right? They are at infinite distance, force on them would be 0, and probably you cannot say that they have any kind of potential energy. Now the thing is, let's say you take these charges and move them to a finite distance. Instead of keeping it as an infinite distance, you have given it a finite distance. If there is a finite distance, now this finite distance, now the force is not equal to 0. And of course, there has to be some work done to move these charges from infinite distance to finite distance. So we call this change in potential energy as the work done to move these charges, these two charges, not just one charge, but these two charges In this case, we are assuming to be the like charge. The analogy that we saw was for negative charge, which is not quite a relevant concept when we are talking about electrostatic potential energy. The reason being, we are trying to interpret it from moving from like a finite, like a zero distance to an a finite distance. Rather, it should be from an infinite distance to a finite distance. So if you move it from an infinite distance, these two set of charges just kept as infinite distance, and let's say one of the charge, let's say in this case this q has been moved to a finite distance, okay, from that infinite distance. So now this you or that whatever external force must have done some work to make it happen, and this change in potential energy is basically that work that you have done. Okay, so the change in potential energy is nothing but the work done to move these charges from an infinite distance to a finite distance in the vicinity of each other. Okay, now in this case, what we will do is we will say this finite distance, we are going to assign it a value and calculate everything. Okay, this finite distance, we are going to assign it a value and calculate things. So let's say this charge, there are charge q1 and q2, and let's say this q2 is that charge which has been brought from infinite distance from q1. Okay, this initially initially the distance between them was infinite, and then you brought them to a final distance which is like a finite one, which is r. Okay, so some work has to be done, and that work is what's stored in the form of potential energy. If you remember that case where we were pulling up the ball against the gravity, we have been doing some work. And similarly, even in this case, there is an electric field from q1 which is repelling q2. Okay, so you are basically trying to put this charge at some finite distance from q1. Let's say in this case that finite distance is r, and you say that now this charge q2 has gained some potential energy, but rather not just q2, both q1 and q2 as a system as a whole has gained potential energy, right? So what is the potential energy? That potential energy or change in potential energy is nothing but the work done to move that charge from an infinite distance to a finite distance. So basically, I would say if the potential energy at infinite distance was it's going to be zero anyway, and we are going to say the change in potential energy is the work done, and it's going to be ur minus u infinite. Ur is nothing but the potential energy of this system at this distance r, and this change in potential energy is the basically work done. All right. So that being said, you would be defining it using the well-known quantity that would be using your electrostatic potential. Okay, let's say this charge q1 has a potential v1 at this point. Okay, as a potential v1 at this point, and v infinite is 0. And what is the change in potential? Change in potential from bringing from infinite is going to be v1 minus v infinite, which is going to be how much? v1 minus 0, basically v1, that's it. Okay, so v1, and let's give it a name like v1r, since it's at a distance r, etc. And you would say that this is the change in potential for bringing this charge q2 from there. But what is the work done, guys? If you remember, the work done was nothing but q delta v, and which is the charge that has been moved in this case, and it's going to be q delta v, and which is going to be like q2 delta v v1. Okay, so if you're noticing this equation, the change in potential energy is nothing but charge that has been moved from the infinite distance to that finite distance r multiplied by change in potential. Okay, basically it's q2 into v1, that is it. And similarly, we can say that not just charge q2 has been moved from infinite distance to finite distance, but rather q1 has been moved from infinite distance to finite distance. That means some work has been done to move this charge q1 from infinite distance to finite distance. What is that? That is nothing but q1 into v2. V2, let's say, is the potential. Okay, let's come to this. Okay, it's the same thing. There is no difference in this. You notice it. I hope you understood the first one. Now what is the work done? What is the work done to move this charge q1 from infinite distance to this distance r? It's the same thing, right? If I'm moving q2 from infinite distance to r, from infinite distance to the distance r, or if I'm moving this q1 from infinite distance to the vicinity of q2 with the distance r, it's the same thing. So what would be the change in potential in this case? Let's say the potential at this point due to charge q2 is v2. Then we would say, the work done in this case is going to be q1 into v2, or q1 into delta v, which is nothing but q1 into v2 minus of v infinite. Okay, so it's the same thing we have written over here. So finally we'll write it down as q1 into v2. Right, simple. So, but aren't they having the same potential energy? Yeah, that's true. Okay, so you would ultimately find out that q2 into v1 is equal to q1 into v2. What is v1? V1 is the potential at a point, at a distance r away from it. Okay, due to charge q1, which is going to be k into q1 divided by r. And similarly, what is v2? v2 is equal to k into q2 divided by r. Okay, try to multiply v1 with q2 and v2 with q1. They are equal. The same kind of thing. Okay, so it's basically defined as if the change in potential energy or the potential energy of the system is defined as bringing one of the charges in the system from an infinite distance to a finite distance in the vicinity of the other. Like in this case, it's r finite distance in the vicinity of the other charge. All right. So yes, in this case, when we are having one charge, what did we say? We said that the electrostatic potential energy in this case is going to be U12 due to system of charges 1 and 2, because we generally do not define any potential for q1 alone. So think about it. If you had to just bring a charge q1 from infinite distance to this point where another charge q2 does not exist, have you done any work? No, right? You haven't done any work against some electrostatic force, and you haven't created any electrostatic potential energy. So if at all there is another charge, then and there only you have this electrostatic potential energy. Electrostatic potential energy as such is defined for a system of charges. All right, and when we have, let's say, three charges q1, q2 and q3, and q1, q2 being placed at a distance r1, and q1, q3 being placed at a distance r2, and q2, q3 being placed at a distance r3. Let's say there are some three charges. They are placed at some distances r1, r2 and r3. The distance between them are like r1, r2, r3 as given in the picture. So what happens in this case? In this case, you have to actually imagine as if there existed only one charge initially. Okay, both of them did not exist initially. You brought q2 from infinite to this r1 distance over here from q1. Then what happens is, then you will, we are trying to calculate the electrostatic potential energy. Then what you would do is, you would assume as if q1 and q2 now exist, but q3 did not exist, and you brought this q3 from infinite to this position. Okay, now this position is at a distance r2 from q1 and r3 from q2, and q1 and q2 is a system that has already been brought to place. So it's basically, it is, just assume that existed only one charge, Q2 has been brought into the vicinity of Q1, and then Q3 has been brought into the vicinity of Q1 and Q2. So it's basically like what you have done a work to assemble these charges or the system of charges. Okay, so the electrostatic potential energy of a system of charges is the work required to assemble these charges in the given configuration, and that too as if the system initially existed at an infinite distance. But you need not necessarily think about it like this. Q1 and Q2 and Q3 did not exist. I mean, like, they existed all at infinite distance from, or a very large distance from each other, and it is as if this Q1 and Q2 and Q3 has been suddenly brought to this position. Okay, so that is it. And in this case, you would be adding the potential energy of all the like, as if you're going to go by 2 and 2 charges. Let's say you will be saying, let's say, due to charge Q1 and Q2, potential energy due to charge Q1 and Q2 as U12, like what we calculated earlier, which is nothing but Q1 into V2 or V1 into Q2. And similarly, due to charge Q2 and Q3, it's going to be U23. And then due to charge Q3 and Q1, the potential is going to be Q31. You're going to basically add up all these three potentials. Okay, you're going to add up all these three potential, U12 and U23 and U31. Why? Because this is the total amount of potential energy comprised by the system. Okay, this is not by an individual charge, but an individual charge also has some potential energy. We'll come to that point, but in a given system. Okay. So this is the potential, the net electrostatic potential energy. Okay, this might be due to Q12. This is the potential energy due to this, which is going to be like you can say this is going to be K into Q1 into Q2 divided by R1. Okay, basically K into Q2 by R1 into Q1, and this could be said as like K into U31, which is similarly going to be like K into Q1 Q3 divided by R2, and this is going to be U23, which is going to be K into Q2 Q3 divided by R3. You'll add up all those three potential energies and say this is the net electrostatic potential energy of the system. Okay, of the system. We'll come to this point, we'll understand this better with all the kind of model problems that we have, and but the thing is, it's for the system. So does that mean this individual charge does not have any potential energy in the system, or bringing this from an infinite distance to this finite point did not create any potential energy? Yes, of course it did. Okay, we'll come to that point and we'll understand it as well. Okay, so but this is how you will typically do it. This is what we were trying to do. This is an equation, where you can directly apply this equation to calculate it for any such given combination of charges. So let's say instead of this 3 charges, you have n such charges. You can basically multiply charge Qi with the potential that it has created by one of the charges. So this is like saying, in this case, this, if I'm going to just expand this term, try to understand this term. So this is total potential energy of the system. Okay, if you are observing, I have written it instead of change in potential energy as directly potential energy, because you're going to say the potential energy at infinite is 0. Okay, this is nothing but delta U. And what is this equal to? This is equal to, this comes from all the kind of two things will repeat twice. So this is as if writing 1 by 2 Q1. In this case, let's say this is charge Q1, and that what is the potential on it due to charge Q2 is going to be K Q2 by, this case, R1. Okay, don't get confused by R1, R2, R3. Okay, this is just kind of a mathematical representation. You'll soon understand that. Similarly, you'll write down for Q1 into K into Q3 by R2, and then this thing will repeat again for yes, we don't have a space. Okay, this thing will repeat, and you'll notice for an example in this case there would be again Q2 into KQ1 by R1, but this is a repetitive term. Doing the same thing, this is a repetitive term. Okay, electrostatic potential energy, it's a scalar quantity. You're adding it twice for no reason, so just you'll be removing this. Okay, electrostatic potential energy is also a scalar quantity, so that's why we have this half. Similarly, if you do it for every term, you'll observe a repeating term everywhere. For an example, again there would be like a Q2 into K Q3 by R3 plus of Q3 into K Q1 by R2, the repeating term. If you notice the second term and this term is repeating, and then you would have Q3 into K Q2 by R3. Okay. Yeah, hi Cheshwara. Yeah, hi students. Yeah, very good, very good. No worries, Cheshwara. We have just started with the concept. We are yet to get into more numericals. All right. So that is why we have this. You can also apply this equation. This again a mathematical equation. If you have noticed here, instead of Qi, instead of Qi sigma I, it has been written as Qj by Rij, and K is of course taken outside. Don't worry about it, you will slowly understand it. If you didn't understand it, this is going to be like super easy. In fact, one of the easiest thing. So let's get into one more important concept before we get into problems. So yeah, this is also the same thing. If I've told you, I hope you understood this point. So there will be two repetitive terms. If you remove all the repetitive terms, you'll be left with the same term as we derived earlier. It's basically U12 plus U23 plus U31. All right, and what is this second thing that you are seeing over here? The same thing, but here J is not equal to I, again divided by half. It's the same thing if you work around it. All right. So, but what about a single charge? I told you the single charge also has a potential energy. Okay. For an example, in this case, Q1 has some potential energy. Right? What is the potential energy of Q1? So when would this be useful? In many cases. So the potential energy of Q1 in this case is going to be, just I'm going to call this as UE1, is going to be K into Q1 Q2 divided by R2 plus that of K into Q1 Q3 by Q1 Q2 by R1, sorry, quickly correct this, by R1, and this is going to be K into Q1 Q3 divided by R2. Now what is this? This is basically this I have written down the expression, but what is this? This is basically Q1 and the potential at that point of Q1. Okay, potential due to rest of the charges at the point Q1. This is due to potential due to Q2, charge Q2, and this potential due to charge Q3. It's basically the total potential at that point. which can be written in this kind of expression. Okay, whatever charges, just add them up. All right. But as such, this is electrostatic potential energy is defined for a system of charges. All right, guys, a very simple question. Get started on this. You'll get to understand it. Up until now, we learned that electrostatic potential energy for a charge does not exist, but for a system does exist. But as such, one charge in a system can have some potential energy depending upon its position. Okay, and the number of charges. So there are two factors that determine the potential energy of a very important concept. There are two things that define the potential energy of your the electrostatic potential energy or electric potential energy. There are two factors that depend upon that define or that okay, the magnitude of electrostatic potential energy depends upon two things. One, the charge magnitude or the charge of the value of the charge or the magnitude of charge. Just a moment, guys. The magnitude of the charge or the magnitude of the charges in the system, all the charges in the system, and the distance between them. A very similar concept like what you have seen in your Coulomb's law, and the distance between them. And what is it? You are going to add up for each and every the potential energy for each and every charge. Okay, all right, let's get into a problem and start understanding this concept really more efficiently. So three charges Q, Q, Q are placed at the vertices of an equilateral triangle. Find the magnitude of potential energy. Get started on it, students. It's a very simple concept. There is no complication in this concept, so try to work around it on your own and come up with an answer. And start commenting it, guys. Start commenting it. Of course, I'm noticing your comments. So yeah. All right. So three charges Q, Q, Q are placed at the vertices of an equilateral triangle of side A. Then find the magnitude of potential energy. Isn't it an easy problem? So first of all, what are the system that exists? This is A, distance A, this is distance A, this is distance A. Good, Cheshwara. I hope you have done this question. I'm going to call this guy as 1, this guy as 2, and this guy as 3. What is the total potential energy of the system? There would be a potential energy due to the charge 1 and 2, which I'm going to call as U12, and then due to charge 2 and 3, and then due to charge 3 and okay, charge 1 and 2, and then charge 2 and 3, and then we had also the charge 3 and 4. Just add it up. It's really that simple. And what is the potential U12? U12 is equal to U13. Since it's an equilateral triangle, think about the distances. Distances are equal. Distances are equal. Is equal to U23 is equal to U31. How much are they? K into Q square by A square. Right? Sorry, A. I'm really sorry. This is just A. This should not be A square. This is A. Oh, yeah. Divided by A. So yes, how did we get this? You can say U12 is nothing but Q into Q1 into V2, something like that. In this case, Q1 is Q. What is V2? If this is 1, this is 2, then V2 is going to be K into Q2 by R, or in this case Q by A, which is going to be K into Q square by A. Simple. And similarly you can do this for U13 as well. U23 it's going to be Q2 into V3. What is the potential due to charge 3 at 1 at 2, I mean like at the position 2, it's going to be Q into K into Q by A, again K into Q by A, so it's basically K into Q. Similarly, you'll get this to be equal to U31. So basically your total potential energy, or the net potential energy, whatever you like to call it, is nothing but U12 plus U23 plus that of U31, isn't it? It's nothing but basically 3 times K Q square by A. Is it? Just add them up. Okay, just add them up. All right, simple. The answer should be B. Okay, it's not going to be 0. It's not, of course, going to be by 3A. It's not going to be just due to one charge. All right, let's move on to next question. Then I believe that was a very simple question, just a starter question for your understanding. Now let's say there are 3 charges, capital Q, plus Q, and plus Q, are placed at the vertices of an isosceles right angle triangle with similar sides of length A. If electrostatic potential of the system is 0, can electrostatic potential of a system be 0? What does it mean? Does that mean the system does not have electrostatic potential energy at all? Yeah, it is possible. When is it possible? Think about it carefully. Try to think about the question up until then. You know what, there are 3 charges as told to you. Now they are also saying that net potential energy is 0, and 2 charges have been given of same like plus q value, and it's an isosceles right angle triangle. This is A, this is also A. Well, this should be root 2A. Try to work around this question, and first of all, guys, try to eliminate few options in this. Think about it carefully, and eliminate few options. Should we get into it then? See, first of all, electrostatic potential energy has to be 0. So this is again 3 charge case. So we can say U total or U net is equal to U12 plus U23 plus U31. I'm sorry, U31. If this has to be 0, that means something has to have a negative sign, and that negative sign will only arise if Q is negative, right? So A and B cannot be correct. It has to be one among C and D, right? Easy. All right, let's move on to this thing. So first of all, this is an isosceles triangle. This would be A, this would be A, this would be how much? This would be root 2A under root of A square plus A square. And then you are going to define the potential energy of the system. One would be due to Q and plus Q. So one would be due to, like, let's define the name this way, due to the charge plus Q and Q. I'm going to call them as Q and plus Q, which are placed at a distance A. And then you have this is the first one, which is due to this, this side. And then you have the plus Q and plus Q, which due to their interaction have a potential energy. This is going to be the second one. Okay, let's call this as U1 and this as U2, which is going to be basically due to plus Q and plus Q placed at a distance A. Okay, this is going to be the second one. Then there is going to be the third one, This is due to the root 2a distance between capital Q and small q. This is going to be due to capital small q and capital Q, or capital Q and small q. Add them up and say this is equal to 0. That's it. So if the net potential energy is 0, it says that U1 plus U2 plus U3 should be equal to 0. That's it. That is all you need to do. Now rest is math. How much is U1? This is root 2a, this is a. U1 is how much? I'm going to call this as system 1. How much is U1, guys? K into capital Q into small q divided by a. How much is, if this is the second one, how much is this like U2? U2 is going to be K into Q into, again a Q, it's Q square divided by A. Okay, and U3, that is due to this interaction. How much it is? K into Q divided by small q into capital Q divided by root 2a. Now we have something like this: U2 plus U1 plus U2 plus U3 is equal to 0. Now just write down the equation. Don't worry about the sign. The math will take care of the sign. So don't worry about it. Okay, and just work around rest of the equation. First of all, if I'm going to simplify this equation, K is out, A is out, A is out, A is out. Similarly, 1Q you are going to lose everywhere. Okay, so the final equation would look something like this: Q plus of, Q plus of Q plus of Q divided by root 2 equal to 0. Okay, of course now you understood that it should have been negative. Just take it on the other side. So we had the equation something to be like this: U plus 1 by under root 2 is equal to minus Q. Let's now simplify this form. The value of Q, which is going to be minus of root 2 into Q divided by root 2 plus 1. That is it, guys. Really that simple. Okay, so what did we do? We basically had we did the same thing. Basically system of 3 charges. We basically took this U1 and we took the U2 and U3. U1 is due to the interaction between these 2 charges, Q, capital Q and small q, separated by distance A. And then U2 is nothing but this potential due to system of charges interacting at a distance A, which is due to plus Q and plus Q interacting with each other at a distance A, and which is due to this plus Q and plus Q. And again we had this plus Q and this capital Q, which are interacting at a distance root 2a, which we call as U3. Okay, this is just indicating the function. This is not multiplication. I'm just saying that it's a function of distance between the charges. So yeah, we wrote down U1 is equal to K into Q by A, and U2 is equal to K Q by A. This is all small q, and then we have K into Q by root 2. I added them, 3 of them, and said they are equal to 0. And V initial itself, we deduced capital Q should be a negative, should have a negative sign, or should be an unlike charge compared to this plus. That's it. It's as simple as that. All right guys, so the answer should have been All right then, let's move on to next question then. This is an interesting one. Now think about it carefully. ABC are 3 points on a circle of radius 1 meter. These points form corners of an equilateral triangle. A charge 5 coulomb is placed at the center of the circle. The work done in carrying a charge of 1 coulomb from A to B. Why don't you get started on this question, guys? This is a very simple question. This is the beginning. Alright. What about this station? What should be the answer? You're welcome, Cheshwara. You're welcome. And what should be the answer in this case? Alright, let's understand this question first. So there is a circle. Okay, let me do a thing. Let me redraw the circle. Just a moment, guys. Okay, now the circle has 3 points. Okay, this is a circle. First of all, the circle has a radius of 1 meter, and the circle has 3 points. Very good, Cheshwara. Very good. So there are 3 points, and these 3 points form the what? The side of an equilateral triangle. Okay, there's 3 points. So, okay, any such question? This is actually a very simple question. Some, we are not going to deduce what is this distance going to be and all. I'm going to say this is an equilateral triangle. Yes, good, Cheshwara. Very good. Why 0? Okay, this is also some A. This also some A. This also some A. Now, what is being asked is a charge 5 coulomb is placed at the center of the circle. Now you have something like a 1 coulomb charge. Okay, let's say this is A, this is B, and this is C. You're trying to move this. There's a 1 coulomb charge, and you're trying to move this 1 coulomb charge from A to B. This was the final position. Okay, good, Cheshwara. Very good. And what have we done over here? I have moved this from here to here again. Like, let's say this is how you have moved it. This is how you have moved it. It has been moved all along the same. Now the point is, I have moved from A to B. What is the work done? So do remember, first of all, in like up until now, to move this 5 coulomb charge, no work has been done. Okay, to move this 5 coulomb charge, no work has been done. Now The question arises, what is the work done to move from A to B? A 1 coulomb charge from A to B. What is the potential at point A or point B minus that of point A? And in this case, potential exists due to two charges, right? One is due to 1 coulomb and another one is due to 5 coulomb. Of course, now we have two charges. Already your 5 coulomb has been brought to the center, and the simplest explanation, if you understood, is like it's an equipotential surface. This circle is a equipotential surface. This is the simplest way to understand it. Can we say this is nothing but Q? Let's say okay, Q2 into delta V, where delta V is 0 and Q2 is 1 coulomb. Okay, because this is the center and this distance is also R or 1 meter, whatever it is, and this distance is also R. So it's basically you haven't done any work, so this is 0. And the other way to think about it is, it's basically, if I'm going to go by UA, UB, rather than writing down this thing, this could be simply be written as K into Q1 Q2 divided by like 1 meter, whatever it is, or R in this case, minus of K into Q1 Q2 divided by, going to be 0. Very good. That's it. All right. So no change in potential is what you need to observe. No change in potential. Delta V is 0. Why is this all happening? Because your electrostatic electrostatic force is a conservative force. Hence, it only depends on initial position and final position, or final position and initial position. Okay, and this is an equipotential surface that you understood it. Okay, from 5 coulomb it's an equipotential surface, right? All right. I hope this is clear, guys. Okay, U final is equal to U initial or UB is equal to UA. That should be clear. And the best or the most important thing to notice over here is electrostatic force is conservative or not conservative? Is conservative. We call this to be conservative, which is dependent upon initial and final position. Depends only upon initial and final position. That's what is conservative. So if the electrostatic potential energy hasn't changed, that means the work has also not been done. Alright, let's move on to the next question then. Three similar charges plus Q are placed at the center of an equilateral triangle. Now the distance between each charge increased by further 2a. The work done to bring this charge in the new configuration is how much? Get started on this question, students. Okay, a simple one. Try to think about it. What has been asked? There are three similar charges plus Q which are placed at the corners of an equilateral triangle of side A. The distance between the charges increased by 2a, further 2a. Okay, to more clarify your question, it should have been further 2a. The work done to bring these charges in the new configuration. What is the work done to assemble or deassemble from the initial configuration and assemble them in the new configuration? Think about it carefully. Take your time to think about it. Have you tried it out, guys? Should we get into it? Before that, let me ask you a question. Okay, what did we say? We said something like this: work done or work external or whatever, work done or work external is equal to U final minus U initial. Okay, and what about your U as such potential energy? Is it inversely proportional to the distance between the charges? Yes. So that means in this case, have you increased or decreased the distance? You have increased the distance. You have increased the distance. What has happened? The potential energy should be decreasing. The potential energy of final is less than that of initial. What is happening? Your answer should be over here. Sorry, over here your answer should be negative. Right? That means your answer should be negative. It cannot be positive. Think about it carefully. That way you can eliminate option A and C. Okay. Even among this, you can quickly guess the answer. But anyway, let's do the problem. So yeah, this should be basically be less than 0. Okay. All right. Let's move on to the question. Let's start understanding what the question asks. Initially there was a charge, like 3 charges like this. So let's understand it from the perspective of how we would solve a problem. There is a Q, Q and Q. Okay, now what has happened is initially they were all at a distance A from each other. That's only possible if they are placed at the corners of an equilateral triangle. Initially they were at a distance A and A. Now the distance between all the charges have been further increased. Each charge is further increased by 2A. That means this was the initial configuration. Now what did you do? You did something like this. You pull these charges apart and you made them look something like this, this and this. You're going to erase this initial part. I think that is quite understood at this point. Now this is sort of the final distance. What have you done? You have increased the distance by 2A each. That means the distance between them is 3A. Right? It's A plus of 2A. So this is going to be 3A. This is going to be 3A. This is going to be 3A. Alright, that is it. Now the question arises, what is the work done? It should be negative. You know this thing. Now if this is the initial and this is the final, okay, now we can, I think, comfortably label it. This is the final configuration of the charges and this is the initial. What is the work done? Work done from initial to final is going to be U final minus of U initial. What is U initial in this case? You're going to add up all this 3, right? K into Q, Q by A square, K into Q, Q by what is U initial? Sorry, what is U initial? K into Q, Q by A square plus of K into Q, Q by A, K into Q, Q by A, K into Q, Q by A. Let me write it down. So your initial configuration, okay, your initial configuration, what was it? Was something like this. you add a q, you add a q, you add a q, and this q is separated by distance a, this q is separated by distance a. Yeah, you're welcome. Okay, this q is separated by distance a. This is going to be k into q into absolutely Chesh. Yeah, absolutely. So this is going to be, first of all, if you understood 1 2 3, if I'm going to label this, I think we should not be doing this very often anymore. So this should be like k into q by a square, a, and plus of k into q by a again due to this 2, and then there would be third one, which is going to be k into q by a. Right, so you would have something like initial configuration as 3 into k into q square by a. What about the final one? Okay, final one, again we will have something like this. 3 charges are there, and the distance is now increased to how much? 3a, 3a, and 3a, q, and q. So now, what is the potential of this system, which is going to be u final, which is going to be k into q2. Let's say this is 1, this is 2. Due to them, it is going to be k into q by 3a, plus of, between, due to 2 and 3, it's going to be k into q by 3 again. Again, due to this 2, like 1 and 3, it's going to be k into q by 3a. What are you going to get? Something like 3kq square by 3a, which is going to be kq square by. Right? So this is your final potential energy, and this is your initial potential energy. To subtract them, you will get the answer to your question. That is, what is the work done in bringing this charge in this configuration? Okay, so what is the work done now? I write down from the earlier one, from 1 and 2, we know this is going to be u final is going to be kq square by a minus of initial is going to be 3kq square by a, which is going to give you minus 2kq square by a. Right, this is the work done. Negative sign. Potential energy has increased or decreased? Potential energy, the final potential energy has decreased. You haven't done any work. The work has been done by the system. Hence, this is -1. Okay. So it should have been simply, D, the question. Alright, let's get into the hi Chitra, hi. Alright guys, let's get into the next question then, and I believe this is going to be super interesting, but given that you are making use of and understanding the concept clearly. Up until now we were dealing with triangles. Now we have got into a situation where we have got into a square. Same question, same kind of question. I mean, like, it's not the same question, same kind of question. Yeah, hi Chitra, just get started on this question. And plus q, minus q, plus q and minus q are placed at the vertices of a square of side A. Length of the side is how much? A, and A. Okay. Now find the magnitude of potential energy of the system. Whether it is going to be 0 or whether it is going to be like kq square by under root 2 minus 4, or whether it's going to be like kq square by under root 2 plus 4, or whether it's going to be kq square by 4 minus. It's something that maybe I wouldn't say get started with the options itself. Maybe you want to get started with the approach. Count the number of like two charge system and then go about this problem. Take your time, try it out. It's a simple one. Try to think about it. Try to think about it. If you're missing something, what is that you're missing? If you're not getting the answer given over here, some roots are appearing. Am I doing something? Am I doing something wrong? If not, where am I going to? If you're doing it correct, really good. Not. Generally, first timers will make a mistake over here. Like already students who are well off with the concept or who have been already introduced to the concept will not make. This generally happens in terms of your counting. Okay. All right. Let's do a thing. Let's get into this. So first of all, guys, there is charge 1. All this as charge 1. This has charge 2. This has charge 3. And this has charge. If I'm going to ask you what is the potential energy or the net potential energy of the system, it's going to be U12 plus U23 plus U34. Of course, you're moving in a cyclic manner, but if you remember that equation, it's not all about cyclic manner, guys. U34 plus of U41 plus of. Why again a plus? Why did we again write down a plus? U13, there would be a potential energy due to these two charges as well, and similarly due to these two charges as well, right? And there would also be an U due to interaction of charge 2 and 4, right? Isn't it? Yes. Is this how you go about it? All right. So one way you could have done it is just simply said, sigma kq k1, kqy into this thing. Or else a very decent way of understanding this could be using permutation combination. If you had made use of permutation combination, you would have understood there should be 6 system of 2 charges. Okay, 4 charges, select 2 charges among them. How much do you get? 4 factorial by 2 factorial divided by 2 factorial. Right, this would be what? 4 factorial divided by 2 factorial divided by 2 factorial. You can say this is 3 into 4 and this is 2 to 6. Okay, right? Is that it? Or the other way is, if you notice that equation, it is basically 3 into 3 plus 1 by 2. Okay, anytime if you would like to verify, just make use of this the selection method, okay, combination method. Okay, so out of this 4 charges, how many unique combinations of 2 charges you can pick? You can pick 6 unique combinations. 6 unique combinations. And if you remember, in that case, what did we have? We had something like qi into qi divided by ri qi into qi, something like that, right? Some one qi was there and then another qi was there. You just kept on adding and adding, something like that. For all the charges you had to do it. If you notice that equation, it yields something like, you know, n into n minus 1 by n into n minus 1 by 2. Okay, basically it will come out to be like 3 into 3 plus 1 by 2, which can be written in this way. Okay, isn't it? Yeah, that is it, right? So I'm talking about the how did we get this. If you have any such questions around this, we had an equation. It said potential energy is equal to sigma Qi just a moment. 1 by 2 of Qi into phi. Okay, Qi into phi. In this case, if you notice, it goes from 1 is equal to I is equal to 1 up until n, right? Here how many terms will be there? N minus 1 terms will be there, right? And similarly there would be like n minus 1 terms and n minus 1 terms, and you will find out eventually that this is also nothing but n into n minus. I mean, this combination is yielding you n into n minus 1 combination should exist. Okay, n into n minus 1 such combinations should exist. Alright guys, let's move on to the question. Then this is just to understand. All you need to remember is n into n minus 1 by 2. That is what you need to remember. Rest is easy. Basically it's selecting 2 out of 4 charges or 2 out of n charges, 2 combination of 2 charges system, selecting out of n charges, etc. Alright, now let's move into this question and just start solving it. It's a simple one. First of all, what is you need to write down what is U1, 2. To charge 1 and 2, what is the potential? Minus, this is side A. Let me do a thing. Already understood this point. I'm going to remove this and do one more thing, that is saying that this is how much this side is 2A. And similarly the other diagonal is also root 2A. U12 is how much? U12 is plus q minus q. So that is going to be k into plus q minus q square by plus q minus q multiplied. There will be a minus divided by a. And similarly your U23 is going to be how much? Minus q plus q. Does not matter. It's minus kq square by a. And then U34 is going to be how much? It's going to be plus q minus q. Again it's going to yield minus kq square by a. And what about U41 guys? U41 again minus q plus q, so it's going to be minus kq square by a. You understood an amazing thing. There should be 4 like minus kq square by a. Now how about U13, 1 and 3? Under root 2a again. Okay, again I'm writing it down. Just this is the distance between charge 1 and 3. This is 1, this is 3. What is it? It is going to be plus q, so k into q square, product of magnitude of charges, divided by the distance, in this case root 2a. Now how about U24? U24 is going to be minus q k into minus q, which is going to give you just plus q, right? Minus of minus plus q square by under root 2a. Just add them up. This is what we need to do. What did you get? You will get over here something like 2 into, all right, let me write it down, in the order. So u12, u23, u34, all of them are equal. So if you add up this first 4 terms, what you get? Minus 4k q square by a. Then plus of u13 and u24, if you have noticed, they are also equal, even though the kind of charges that are interacting are different. There it was a positive and positive, there it was a negative and negative. Okay, so you will get something like 2 into k q. So these both are same magnitude, right? I'm directly writing it down there. K into q square by under root 2. Here root 2, you'll get a root 2 over here, and that is it, guys. That is it. Now the rest is simple math. I mean, like, not even a simple math. You have to basically take out something common, k q square by a, to get your answer. Basically root 2. But you know what, you could have thought about this question in a different way, whether the net potential should have been negative or positive. It should have been negative. Okay, all right. So possibly the answer should have been only B. But that's little, once you start working around such problems, you'll get such intuition. Of course, it cannot be 0. Of course, there has to be negative terms, so C is not possible. Among these both, which should have been true? This should have been true, because in such configuration, you'll get it to be negative. But this comes with practice, guys, so don't worry. For now, this is really simple. You should have understood 2 things. One is, all you need to remember is n into n minus 1 by 2 number of system of charges exist. Number of system of 2 charges exist. Let me rewrite this. N into, this is the way to verify it, right? If you have missed out anything, n into n minus 1, or you can also make use of nc2. Number of system of 2 charges exist. Okay, this also can be, you have very comfortable with permutation, combination, and of course your JEE aspirants, you should be, can remember this way. And this also, I guess, would yield something like n into n minus 1 divided by 2. Okay, you're basically selecting a combination of 2 number of 2 system charges exist. Alright, this is how you will verify it. You're missing out something, and do not miss out this, like uneven distances. According to you, even distances are A. Suddenly there comes up, under root 2A, don't miss it out. It's only first timer's mistake, right? Always you will not be doing. Alright, that's why I try to attend each and every lecture carefully. Okay, now this is a very interesting question, okay? Now, 2 charges, 1 coulomb and 1 coulomb, are placed at a distance 2 meters from each other. An external force is used to place a third charge of 5 coulomb at the midpoint of line joining the 2 charges. Okay. An external force is used to place a third charge of 5 coulomb at the midpoint of the line joining 2 charges. What is the work done by the external force? What did we say? Try it out on your own. Of course, the numbers have been given in a very easy manner so that you are able to easily intuit the answer. All right, let's get into the question then. First of all, what was told to you? There are like two charges as 1 coulomb and there is another 1 coulomb over here. Okay, now what are you doing this? Actually, they are separated by how much distance? 2 meters, of course. Very good. Now the thing is, here you have got a 5 coulomb charge. This is 5 coulomb charge. Of course, they are of the same thing, just given a different color because this has just been brought in middle of them. Okay. So where would you bring it from? Typically, you would assume as if this has been got all from infinite and you have brought it to this distance. And now the question arises, okay, this this all existed at infinite and now this came to this distance. So what should I be doing? See, there are two approaches. Okay, what is the work done by the external force? Okay, work done by external force, as you know, could be written as of the total system, where you would have to calculate for 3 you would have 3 terms in them, n into n minus 1 by 2, 3 into 2 divided by 2, 3 and 3. You would have to do u final minus u initial and you would have to calculate the work done. Let me tell you an easy approach. Let us discuss the easier approach. See, up until now, what did you understand? You understood that this is the work done when there is a change in potential energy of the system. But isn't it true? Just a moment, guys. Isn't it true? This charge and this charge has not been moved. It has been kept the way they are. Only this charge, 5 coulomb, has been brought from infinite. So the work done by the external force is nothing but not rather this time. Let's do a thing. Let's not call this as bringing change in potential energy of the system, rather bringing this 5 coulomb charge from infinite to this position. Okay, this is at a midpoint, so this would be 1 meter, and similarly this would also be 1 meter. Now what is the work done now? The work done is the work done to bring this charge from this 5 coulomb charge from infinite distance from this 1 coulomb system of charge to the middle point. So now we can say something like this. What has been the change in the potential energy of 5 coulomb charge? What has been change in potential energy of 5 coulomb charge? Okay, this is a simpler method of understanding things because the 1 coulomb system of charge has not been disturbed and only this 5 coulomb charge has been moved from infinite to a finite distance. Okay, from infinite to a finite distance. This is basically that one parameter which is going to be like at present position, what is the 5 coulombs charge potential energy minus that of U when it was infinite. Work done in assembling the charge. U at infinite you know is 0. And you can say now this is the kind of potential it has. Now what is the kind of potential at just a moment, what is the kind of potential at okay, you don't want to go by typical method, sometimes try to go move by the concept. Okay, maybe you don't want to do the entire thing, you want to just understand what needs to be done. Okay, what is the work done in this case by the external. So if I'm going to say the potential of a single point charge at its position, in this case you are 5C, 1 would be due to, let's call this as 1 and this as 2 and this has some 5, let's give this a name as some X. Okay, so there would be two things, one would be U1X plus of U2X. Okay, it's placed at the midpoint, U1X is equal to U2X, right? We just saw it's at an equal potential, it's at an equal distance from 1 coulomb, so it's on the other side, it does not matter, or however it is placed. So this I'm going to say is going to be 2U. Okay, what is the value of U? U is nothing but K into Q1 Q2 by R square, and you know R is how much? R is equal to 1 meter, and you know the value of Q1 and Q2. K into 5 into 1 into divided by 1, sorry, not R square, again my mistake guys, it should be just be R. I often do this, it's not force, it's work done. So again let me correct this point, basically 1 again, so this is 1, so this is 5K, 5 times Coulomb's constant, and that means what is the net work done from this? You know, this is going to be five into 5K into 2, which is going to be 10 times Coulomb's constant. This is the work done, right? This is the work done, isn't it? This is the work done. So work done, you need not complicate it, rather keep it as simple as work done by the external force is nothing but 10K, which is nothing but work done to move this charge to a finite distance R, this 5 coulomb charge to a finite distance R, in this case 1 meter away from 1 coulomb charge, which is going to be 10 into, I'm just writing down this equation, 10 into 9 into 10 to the power 9, and this would be in joules, this would be simply be 9 into 10 to the power 9, sorry 10. So 9 into 10 to the power 10, I mean like joules of work has been done to bring it to this new configuration, to bring the system to this new configuration. Even to bring the system to this new configuration, this is the amount of work done. This is not the total potential energy. If I'm going to ask you the total potential energy, of course you are going to add the interaction due to charge 1 and 2. Okay, of course going to add interaction due to the charge 1 and 2. Okay, you could have gone by U final by U initial, but this is an easier way of understanding it. You are basically bringing this charge 5 coulomb from infinite to this distance 1 meter away from the 1 coulomb charge. Hence there is a change in the potential energy, or some work is done to do this assembly. Okay, it's really that simple guys. You don't go through the method of like writing down all the things that comes to that is required to calculate the change in potential? Depends upon the question, right? In this case, what is the work done? Only one charge has been brought. Even it can be two charges, then you would have to do it for these two charges separately. Depending upon which charge comes in first, you need to calculate it for that charge, or even if not, you'll get the answer. Don't worry about it. That's just a way of stating it, and still you'll get the answer. Simple one. Alright, answer should have been D. Alright, move on to the next question then. Alright guys, I think this question is a little bit lengthy. Let's take it up tomorrow with other rest of the questions that we have in the upcoming session. So we'll do this. Up until then, you can start trying it out. So let me read out the question quickly. We'll take it up in the next session, tomorrow's session. Don't miss it out. We'll have a quiz. We will have more questions around electrostatic potential energy. We have more and more interesting problems, so don't miss it out. And tomorrow's session, and tomorrow is the real thing for students who have just started with electrostatic potential energy. This is something that you should have understood by now. Okay, all the things that I've been taught is the basics of electrostatic potential energy, but I wouldn't say this is the end of it. There are a little bit more advanced concepts that we'll be taking up in tomorrow's session, so do not miss out tomorrow's session. And students who are already aware of these concepts, you have more things to come up in tomorrow's session. Okay, tomorrow we'll have very interesting problems around them. So just a sample, so there are two charges 5 microcoulomb and are separated by a distance 6 meters. C is the midpoint of the line joining A and B. A charge Q of minus 5 microcoulomb is shot perpendicularly to the line joining A and B with a kinetic energy 0.06 coulomb. Okay, all right. So it is kept at C, and now it is, you can assume as if it is kept at C, and it has been strived with an it has been given some initial momentum or etc., such that the kinetic energy right now is 0.06 joules. And of course, the charge Q comes to a rest at a point D. What should be the distance CD? Note down the question, take a screenshot, work around it. Tomorrow we'll get started with this question. Not only that, we will also get started with more interesting problems around this electrostatic potential energy. It's not the end of electrostatic potential energy. There are more and more problems coming up around this. There are interesting problems around this, and you need to definitely work on them, guys, especially JEE Advanced and JEE Mains aspirant. I don't think maybe the last question, still this may not be the tough question from electrostatics typically have at least not from the potential point of view, but electrostatic potential energy point of view, they would typically have some little bit tougher questions. So tomorrow is the kind of session that you want to attend and understand electrostatic potential energy. Also, do not miss out tomorrow's quiz. And yes, try out this question, guys. And that being said, students, the most competitive gamified IIT JEE battle ever is on, and it's going to happen on 22nd of November. So enroll today and use Murlidharan code and enroll today, guys. Do not miss it out. Do not miss it out, because it's going to be super intensive. Not only that, you can win lots of rewards and prizes like Apple products, Amazon vouchers, and not only that, guys, it's going to be a JEE battle, so a good practice for students preparing for JEE. Do not hesitate to attend such things, because these things are kind of going to train you for your JEE preparation. And yes, guys, it's Unacademy Combat again on 22nd of November. It's going to happen every week, but try to attend every week and enroll today. And just you make use of Murlidharan code. Do not forget to do that. And yes, try to win like top prizes on such as like your Apple products, MacBook Air, and Amazon vouchers. And also it's going to be like a gamified event. And not only that, the UCL Unacademy Champions League is also back. So what's this as just a moment, guys. So yeah, this is going to so this is also back. So you'll be seeing more and more of Unacademy Champions League. So try to enroll them for free and start attending them. and they will also give you amazing prizes. So this is, I think this one has already happened. So this is not the most recent one. Let me just quickly check it out. I don't think it is. Anyway, like 18th of November. Okay, today it was happening, I guess. Okay. So yeah. So anyway, this has happened and this will keep happening. So make sure you are attending Unacademy Champions League, guys, and don't miss it out. And yes, this is for math, and you can expect more in the future. So stay tuned. It's going to be an interesting one for you, for your JEE preparation, of course, and for also to win a lot of vouchers and prizes. And that being said, students, if you're already on an Academy subscription platform, enroll soon to this Optics B2A Basics to Advanced coursework. It's the most comprehensive or the best course for your optics preparation in terms of JEE. We are discussing pretty much everything around concepts. I mean, like the concepts, model problems, and the theory around optics. We are discussing pretty much everything around optics, and that too from basics. Even if you don't know anything, you can start learning it, and even if you're looking for advanced concept, you can start learning it. So everything will go from basics until advanced. And guys, you're already on an Academy subscription planning to enroll to this course. It has just been launched. Come daily to the interactive classes, and not only that, try to cover the like the classes that have been already been covered through the recorded classes. So make sure you are doing this. And not only that, guys, it's a comprehensive course in which I'm taking you from not only just from basics to advanced, but also in which we'll be covering both ray optics and wave optics, and that too in 60 plus sessions. So imagine the kind of concept, the kind of depth, the kind of model problems that you'll be dealing with. 100 plus different kind of concepts, and 300 plus model problems is what we'll be doing in these sessions. So start attending it, and if you have already enrolled to it, do not miss out the recorded classes. And even if you're planning to enroll to it, attend the recorded classes. Try to maintain completeness. Completeness is the key, be it you are on JEE English or you are on an Academy subscription. And that being said, not only that, our team is also on JEE English team is also on Plus. Guys, we have IITians and IITians and head of coaching institutes on this JEE English platform. Of course, as you know, it's a free of cost initiative, but we are also on the Plus courses where we are taking in a structured manner. And we have hosted courses on electromagnetism, differential calculus, and optics B2A, and chemical kinematics, guys. And that being said, not only that, we have also started courses for 2022 aspirants on graph sets relation, redoxon equivalent, concepts, and advanced course on mechanics. So this is the kind of courses that our team has been hosting, and we are live every day, and I come at 7:30 on JEE English. So do check it out. And not only that, we have started Google batch for droppers, JEE Mains and JEE 2021. As I told you, on Academy subscription, we have dedicated droppers batch, and which is going to start from day after tomorrow, that is 20th of November. Start attending it, guys. So this is the kind of coursework that you need for droppers preparation. And so make sure you are attending it if you're already on an Academy subscription. Not only that, we have started a micro course for JEE Mains and JEE Advanced. This is also from the same team, and this also will be starting from or beginning from 20th of November. And that being said, students, do not forget to share this video. Do not forget to be regular to the classes, and do not forget to like this video. Do not forget to click on that bell button and that subscribe button, because that bell button and subscribe button would give you timely notifications. This is something you definitely want to do, and you want to click the like on this video and share this video so that someone in need may get access to this videos. Guys, it's complete lecture. It's in-depth lecture on electrostatics, and you would see the same thing on any such subject on JEE English, or any such topic on JEE English, or any such JEE physics subject that is being taught on JEE English. So do share this video. It's not only just free of cost initiative, but also free of cost initiative with quality lectures. So do share this video, and do not forget to share it so that you are doubling your knowledge, tripling your knowledge by sharing it with your friends on social media. This is something that you definitely want to do. and keep smiling and work hard and smart to achieve your success and avoid gossips every time during your JEE preparation, or be it even in life, for a better success. And that being said, students, if you do not have a Telegram app yet, download it, because you want to get onto our Telegram channel, our JEE English Telegram channel. If you want to get onto it, just download this Telegram app from Google Play Store and App Store and click onto this link. This link is available in the description box below, or you can just type in JEE English to find us. And what would you get once you get onto our Telegram channel? You will get before time updates on every class that is happening on JEE English. Not only that, before time updates, you also would get before time updates on every lecture that is conducted by the JEE English lecturers, even on Unacademy Learning app. So this is one of the platforms that you want to get onto, so that you will get before time updates on every class that is being conducted. And these are all like classes that are being exclusively and completely being conducted in English. So especially it would be useful for you if you are looking for classes in English. So that being said, guys, and also for if you're preparing for your JEE Advanced, etc., this is one of the channels where we are giving out lectures completely in English, that too until JEE Advanced level. So definitely a Telegram channel where you want to be on and stay updated on every class that is happening, and try to maintain completeness. And that being said, guys, units, dimensions and measurements has been completed. What do I mean by completed? We have completed everything around units, dimensions and measurements. This includes dimension analysis, error analysis, units based problems, and measuring instruments like like vernier calipers and your screw gauge, and least count analysis. Many things. That is not many things, actually. Let me tell you, this is the easiest chapter, but many things in just 4 to 5 back-to-back session. This plus a 5th model problem session is what you have, and this is the complete lecture series, which is all available for free of cost on Unacademy Learning app. And guys, you can also check out some of the lectures on JEE English, where we have some lectures on JEE English as well. But the thing is, what, on Unacademy Learning app, the thing is, we have discussed more model problems, different kind of model problems, with a perspective of taking it in a revision mode. So this is something that you definitely want to attend if you are a 2021 or also you are 2022 aspirant. You have already completed it, and if you're looking for a quick revision, this is the thing to attend. And why? This is definitely the easiest topic for your JEE preparation, and 2021 aspirants, why this is the best topic for you, and that too at this time, because you definitely get 2 to 3 questions combined, your JEE Mains and JEE Advanced every year, guys. Every year you can check out the paper, you will find at least 2 to 3 questions in your JEE Mains and JEE Advanced combined. So both these papers combined, you will find 2 to 3 questions, and it's the easiest one, less time consuming one, and all that requires is 5 sessions, guys. That's it. Yeah, that is it. So do not miss it out. Try to attend them and try to maintain completeness, beat any kind of topic. And this is the easiest one where you can maintain completeness. Not only that, this topic takes very less time even during your exam. So definitely go topic. The easiest problems would come from units, dimensions and measurements. Hence you want to maintain completeness and complete this topic, guys. And it's all available on Unacademy Learning app, guys. It's all available on Unacademy Learning app. And students, if you don't have an Unacademy Learning app, just do download it by typing in Unacademy on your Google Play Store and App Store, and the first search result is going to be Unacademy Learning app. And once you find the search result, click on this, and do not hesitate to click on this install button, the most downloaded learning app. And guys, we are impacting near about 7 million lives a day. And that being said, once you install this, you will get live updates on every class happening on Unacademy Learning app. Any lecture that I conduct, you will get updates once you start following me. And not only that, students, a very important part is it's not just about live updates. It's also about quizzes that are going to happen tomorrow, and many more things like Unacademy Combat, etc. You can attend from Unacademy Learning app. And yes, definitely do follow me. Click on that install button so that you get live updates. Right now, capacitor classes are going on. Try to cover them. Try to maintain completeness along with electrostatics, and do definitely download Unacademy Learning app. Of course, it's a free app, guys. So that being said, students, if you are looking for a champions tool for your JEE preparation, it's going to be Unacademy subscription any day. Why do I say that if you're looking for a champions tool for your JEE preparation, it's going to be an academy subscription. What is so different about an academy subscription? On an academy subscription, you will undergo an extensive structured program with the best educators across the nation, and you can move according to your priorities and preferences over an academy subscription platform. So what all do you get? You get daily interactive classes with the best educators. Not only that, you'll move in a structured manner where every fourth class is going to be a doubt clearing session. And along with that, you'll be attending quizzes and mega quizzes and also national level test series, guys. So that's the difference, where you get to attend, a national level test series on, a very interactive platform where you get access to leaderboards and dashboards. You come to know about your standing, you come to learn about your mistakes, you tend to improve upon your, all your learnings, and you tend to improve upon all your your learnings, and you learn from your mistakes, and these kind of things are possible on an academy subscription platform, and that too with the best educators across the nation, and that too in multiple languages as you require. So hence this is a champions tool. And guys, how do you get this champions tool? All you need to do is click on the left hand top corner extension bar, and then click on to this plus button, and then you'll choose IIT JEE as your goal. And with this, you'll be preparing for both your JEE Mains and JEE Advanced, and then you'll click on this get subscription button. And guys, let me tell you, with one subscription you will get access to unlimited number of programs. So that is the beauty of an academy subscription. It's one subscription, unlimited access throughout the period. So this all comes at a price of less than 70 rupees a day. All you have to do is pay less than 70 rupees a day, 2100 per month, to get this an academy subscription. Especially if you're going for a 24-month package, this is the price that you want to pay. This is a 2-year long journey. This is typically meant for 9th, 10th and 11th class students, and also 8th class students can go for it. This is the time to get started, guys. And that being said, do not forget to apply Murli Live coupon to get to this price point and to avail best discount on any of your Unacademy subscription purchase. And that being said, students, we also have convenient payment options for you, where you do not have to go through the hassle of paying all the fee at once. So this is our in-house payment option. As you go on to the payment page, you will find out that we have pay in parts option, which you can make use of to split your payments into multiple parts, and you don't have to go through the hassle of paying all the fee at once. We also give you the access to no cost EMI, where you don't have to bear any interest on your EMIs, guys. So your easy monthly installments without any interest is also something that is available on our Unacademy subscription platform. And guys, the best thing is these two payment options take away the burden of paying all the fee at once. You may want to check it out. And not only that, guys, you can make use of debit card and credit card based payment options to also pay your Unacademy subscription fee. But that being said, these are two interesting payment options which take away the burden of paying all the fee at once. And not only that, students, if you are in long term and dropper, let's say you are a dropper, you're in long term, you are in 12th class, and you're looking for an ideal program to join, and that's going to be your 12-month subscription program, which is going to cost you less than 2,900 per month. This all is going to cost you less than 2,900 per month. And what do we have for you? We have dedicated droppers batch, we have dedicated programs going on for you. We have individual programs going on for you, just like optics B2A. And yes, students, this all comes at a price of less than 2,900 at a price of 2,888. And we have 7,000 plus materials for your JEE preparation and 1,000 plus live programs going on. And you may want to apply Murli Live coupon to get to this price point and to get the best discount on your subscription purchase. So make sure you are not missing out any discount and applying Murli Live coupon and choosing the right kind of program, and not hesitating to give any test series, and not at all hesitating to attend free quizzes that are going to happen tomorrow. And that being said, signing off from me, Murlidharan. Take care, stay safe, bye bye, stay tuned to attend more lectures on electrostatics and electrostatic potential energy. We have more interesting concepts coming up tomorrow around electrostatic potential energy. So do not miss it out. That's going to be one of the most key concepts for your JEE Advanced and JEE Mains preparation. Make sure you're attending tomorrow's session. Take care, stay safe. Bye bye. See you.